Hello there, my name is Stephen from London Flat Roofing. I've put together this model that you can see on screen now because somebody posed a question to me regarding insulation and cold bridging at the fascia point of a flat roof. This is the fascia running across here. For those of you who don't know what a fascia is, a fascia board normally ends the roof where the joists come through. So if you look at this detail that I've got here, you can see that the joists, which are these, overhang the wall. This is a typical detail when you've got a gutter running across. The water will run across the top of the roof down and into the gutter this direction. Now, I'm putting this video together mainly for people who are doing retrofit roofs. This problem doesn't actually occur in new build, and if it does, well, the builders and the architects and the engineers haven't actually done a very good job. This is easily built out, and the insulation should be continuous. So what do I actually mean by that, and what is the problem? So before I explain that, what I'm going to do is that I'm going to explain some of the components that we've got here for you first, and why this drawing is the way it is. First of all, these are all the joists spanning. Obviously, it's sitting on a wall. The rear would up here would probably be the house. There could be a parapet wall this side and a parapet wall this side. It's only this detail down the front that I'm interested in talking to you about at the moment. Now, on a old roof, we come to upgrade the roofing and the insulation. You've probably got these joists which overhang, and you've probably got some kind of decking on top of the joists, just like this piece here. With no insulation in the roof at all, maybe there might be some that someone squashed up there in the past, but we want to bring the thermal dimensions of the roof back to the new building regulation, which is part L1B, which is retrofit of a roof. So we have a choice of how we're going to do this. We're either going to do it as a warm roof, or we're going to do it as a cold roof. So what I've shown you here is the detail of a warm roof, which is this represents the insulation, and this represents the decking. This represents the covering that would go on the top. The greyish board is an extension of the fascia board, because we're not moving the gutter board up, we're actually making the drop for the water to run off bigger. And if you actually look at this detail here and cast your eye, if I can just zoom right in on that, cast your eye on the way that the water is going to run down here and then just drop off the drip into here. So one of the problems with putting a warm roof on is the insulation is above the existing roof level, and you've got this extra height to deal with. But the advantages, and that's why it's used so much these days, if I can just zoom out and change this for you, is that it's easy to install the insulation, because you can just put the boards directly over the top of the old roof, or you can strip the old roof and put the insulated boards over the top of the bare joists. There needs to be a vapor barrier put in, and the vapor barrier goes just along here at this level here. Now, it's important, this fact, because what we've now done by forming this warm roof is that we've made a continuous area over the top that is warm. Once it's put together very, very well. You've got a continuous insulated area, and that's the advantage of the warm roof. It's outside the structure of the building and it's continuous. But hey, there's an area that is being missed, and it's being missed by lots of different people, including the local authority, who should be inspecting this and picking it up. If I bring this around and show you underneath this, and again, we're still looking at this side over here, because this detail over here is how you would do a cold area, and I'll just get onto that for you in a second. So let's just have a look at the warm area. When we do the warm area and we look through here, I'm looking at here, here and here. That's the back of the fascia board, and if I turn that around and have a look here, there's no insulation there whatsoever. So this fascia board is going to be very, very cold inside, and the plasterboard underneath here is not there to do anything to do with the thermal dimensions of this. Heat can rise through here, and this space here will be a warm space, which is why it's called a warm roof. However, that warm air that is moving up will have moisture in it, and that moisture is going to condense on these cold areas, and that's when we end up with a dew point. When the outside temperature is cold, the inside temperature is warm with moist air. The moisture in the air wants to drop out of the air, so it does this on the coldest area. So let's think about an example, and the best example I can think of is your double glazing or single glazing, whatever you may have. But when it's cold on the outside and warm on the inside, you get this water condensing onto the glass. That's what's going to happen at this particular point. So if that starts to happen here, you can have all sorts of problems with rotting timbers. And I've already got some photos which I'll show you at the end of a roof that the same kind of scenario happened because the dew points were not taken into consideration. So why aren't we addressing this area here? Well, it's a factor that where do you stop? I personally now specify to all my customers that when we do a warm roof, we should address it. Normally the customers look at this and they go, well, we'll address it at a later stage when we do the rest of the work. Because the customer's normally got a few scenarios on his mind. First of all, he doesn't really want to put a new roof on because the cost. But then I'm starting to tell him and explain to him that he should be putting a new roof on because of the Part L of the building regulations. And he listens to that and he goes, okay, well, we'll go the extra mile and we'll insulate the roof. Then I start explaining to him about this detail here. And yes, it can be done at a later date. And realistically, it should be, if it is going to be done at a later date, the sooner the better. Of course, if you've got scaffolding up to this level here, the time to do it is when you're doing the roof. Personally, I would do it straight away. That is the best policy. And that means that we would be filling this internal area here with insulation. So the insulation is continuous along this area here and down the wall to that particular point. If we now go over and have a look at the cold roof scenario, the cold roof is when the insulation is put between the joists. So let me just turn this around for you. So this is the insulation I've put here and it's between the joists. And if we look at what's going on here, the new regulations say that this kind of insulation isn't adequate. So more insulation has to be put underneath. So I've put this piece across here. This stops thermal bridging through these joists. So the plasterboard would actually drop down, so you would lose some room inside the property. If we now go and have a look at this from the top and see what happens here, we would have had to have introduced some kind of ventilation here. I've chosen to show that we've used ventilation by these holes which have got a vent in them. This ventilation could be put in a different way. It could be on the fascia board at the front. Now the problem with the cold roof is that you have to open the roof up either by taking the ceiling down below or by taking all the old decking off the top and then putting the insulation in from the inside. So this becomes more costly to do so. It's far cheaper to do a warm roof. So personally, given the choice, I would rather spend the money by doing a warm roof than a cold roof and using the money that I haven't spent on adjusting this and insulating it correctly across the front. Some mistakes that people are making when they're doing cold roofs are that they are not putting ventilation in at all. They're not putting through ventilation in. That means that they're putting ventilation in the front, but they're not putting ventilation across the back so that the air can come up here, move all the way across and come out of the back. Another problem that we're seeing an awful lot of the time is that they're not too sure where to stop the insulation. Some people stop it too soon. Some people stop it just about right so that it's actually over the top of the wall. Some people are taking it too far forward and it's actually blocking the air vents, and that obviously stops the through ventilation. Other things that we're seeing happening is how tight it's actually cutting between the joists is really a problem. And it's a problem because there's a lot of work cutting it in between. If you cut it in between and it's not tight, you're going to get thermal bridging going through because you're going to get the air going through, and that in itself can cause a problem, can cause sweating. Again, let me go over to this warm roof. The reason we like the warm roof scenario is because it's easy to put in. We haven't got to cut in between each one of these. We just put the slabs on top and butt them together. So there's less problems. Generally, no ventilation, so we haven't got that detail to deal with. Less problems with cutting in the insulation between all the joists. So we haven't got that as a problem as well. Well, thank you very much for bearing with me through this long video. I hope it's been of interest to you. If you need any more information, please contact me. My name is Stephen from London Flat Roofing.